In this example video, we're going to look at a second example of a disguised quadratic equation. Again, let's say I give you this equation here, then I tell you to solve for x. Again, you would get frightened because you would be like, x to the power 6? How would I even do this? The first step in solving any disguised quadratic equation is to look at the simplest power of x, in this case, which is x to the power 3, and then we let that equal to some letter. So we go to our equation, we look at our x powers, and we say which one is the smallest or which one is the simplest x power. Here the simplest x power is x to the power 3. So we're going to go to that x to the power 3 and we're going to say let that equal to something. In this case, I'm going to pick the letter G. It's totally up to you. So let G equal to x to the power 3. So if G is equal to x to the power 3, what that means is G squared is equal to x to the power 6. G squared, how do you get G squared? You square both sides. You square this G, you square this x to the power 3, and you get x to the power 6. That's basic exponential law. Anyway, what does this mean? It means that in my original expression, everywhere I see G, everywhere I see x to the power 3, I'm going to replace that with G, and everywhere I see x to the power 6, I'm going to replace that with G squared. What do you know? I have x to the power 6 here, I have x to the power 3 there. So this expression is therefore going to become G squared minus 12G plus 27 is equal to 0. G squared minus 12G plus 27 is equal to 0. And what do you know? This becomes a quadratic equation. This becomes a quadratic equation because you have G squared, you have G plus 27 is equal to 0. So that becomes a quadratic equation. And what am I going to do? I solve this quadratic equation the way I know how, completing the square, using the formula, factorizing. I'm going to choose to factorize this, and I'm going to have, after factorizing this, let's see, product is 27, sum is negative 12. I'm going to have negative 3 and negative 9. So I'm going to have g minus 3 and g minus 9 is equal to 0. You can pause the video, you can do this on your own. So you would get g minus 3 and g minus 9. So what does that imply? It implies that g is equal to 3 and g is equal to 9. So these are my two solutions. So if I go back to the top here, because I said let g equal to x to the power 3, if g is 3, then 3 is equal to x to the power 3. Okay? Then 3 is equal to x to the power 3. Then 9 is equal to x to the power 3. Okay, fairly simple. And then to solve for my x, what do? I raise both sides to the power 1 over 3, or quite simply, I cube root both sides. And what am I going to get? I'm going to get x is equal to 1.442, and x is equal to 2.08. I'm going to get these two answers. So x is equal to 1.442 and x is equal to 2.08. And that's the solution to this equation. Those are the two solutions to this equation. So we looked at this equation here, we converted it into a quadratic equation, then we solved that quadratic equation by the standard normal methods that we know, and we got the answers as 3 and 9, and then we used this conversion here. This is like our conversion. This is where we start converting. We say g is equal to x to the power 3. So if g is equal to 3, then 3 is equal to x to the power 3. If g is equal to 9, then 9 is equal to x to the power 3. And then from there, we just use our basic exponential laws to solve for our x. And we're going to get x as 1.442 and x as 2.08. So this was another example of a disguised or hidden quadratic equation that we just solved. And that brings us to the end of this video. In the next video, we're going to look at one more example of a disguised quadratic equation, and then I will make a video on how you can identify that a particular equation is disguised. In the first two videos, all I've been doing is showing you how to solve disguised quadratic equations, but I haven't actually shown you how to identify a disguised quadratic equation. That's going to be coming up in the next two videos. But until next time, take care.